everyone, welcome to Unit 2, Part 2, and this is talking about Lesson 11.1, which is starting on page 143 in your Springboard book. Now, you're probably going to want a pencil and a highlighter like usual, but I also would recommend colored pencils today to help you visualize some of the pieces we're going to go over. So on page 143, you see these pictures here, and we see in this picture about constructing bridges, in particular triangular trusses shown below. And what we notice is these are comprised of a bunch of congruent triangles. So just like congruent segments and congruent angles, congruent triangles are triangles that have the same shape and the same size. So what we see here is the owner of this company, Greg, wondering that if the two triangles are congruent and he knows the side lengths and the angle measures in one triangle, does he know the side lengths and the angle measures in the other? And the answer here is yes. And basically, if we are going to be able to map triangles onto one another, there needs to be a combination of rigid transformation possible. Either a reflection, a rotation, or a translation, or a combination of a few of those in order to map one triangle onto the other. For instance, we could map here triangle ABC onto triangle DEF if we had a reflection over a line, right? So that was a rigid transformation possible. So what we notice here is in the picture here, ABC to DEF, we can line these up because segment AB is going to match up if we reflect here with segment DE. And we're going to have segment BC measuring up with EF, and segment CA measuring up with FD for AC and DF, if you will, okay? And same idea then also with our angles. We can line up angle A with angle D, angle C and angle F, and angle B and angle E. So we see this down below when we're lining these up. That's why I recommended some colored pencils, because you're able to quickly then line up which pieces go together when you look at their reflection pieces together. So, and then angle A, we said, angle D, angle B, and angle E, and angle C, and angle F, right? So if we notice here, we have this relationship between these, and we have these relationships. If the triangles are congruent, what we're noticing is that A, B, and DE are also going to have to be congruent to each other. All those corresponding pieces are going to be the same size, because we know with rigid transformations, they don't change size. So all of these are the corresponding pieces are going to be congruent, because we know that the rigid transformations do not change size. So what this means for us is we always have we always have some information about the pieces of our congruent triangles, okay? Because we know they're going to end up being congruent. The corresponding parts of the congruent triangles are going to match up to be congruent to one another. So what we see here is that when we know the triangles are congruent, we know their pieces are congruent. So again, AB congruent to DE, BC, EF, and you get the idea through here. So notice the same order here, that A and D correspond and are congruent. B and E correspond and are congruent. So it's really important that you set up these congruency statements correctly so that you can always line up these pieces. And we'll talk more about that later. Now, you'll also see here this word I have written, CPCTC, and what that stands for is corresponding parts of congruent triangles are congruent. What this means, CPCTC, the shortcut, is that we know if the triangles are congruent, their parts that correspond together are also going to be congruent. So that's what the CPCTC stands for. And we're going to use that a lot coming up here. So definitely something you're going to want to write down. So again, if we know these triangles are congruent, we know their pieces are congruent. So if we look here with the given information in the example, they're telling us JKL is congruent to MNP. So we know that the corresponding pieces have to be congruent. So if we know angle N is 50 degrees, we know that angle K is also 50 degrees. And if KL is 2.1, so is NP, because again, they line up with each other. So we're going to look at this example down here to see which of these we know are congruent if possible, okay, given this congruency statement here, okay. So notice they gave us ST here, right? So ST is the last two letters. That means that's going to correspond to YZ. So we know this is also going to be 15. They also gave us angle Z here, the last letter here. Angle Z is 47 degrees. That's going to correspond with angle T in our first picture. So we're going to know that's also 47 degrees. Unfortunately, they don't give us any other information. So really the only two things we can say is that angle T measures 47 degrees and ZY or YZ is 15 centimeters based on how it corresponds. They didn't tell us enough information about the other segments or angles in our picture to say what they measure. So the other two, angle X and XZ, are going to be not possible to find given this information, unless they told us more. Now, if we know we have two triangles that are equilateral triangles, we know that all their angle measures are 60 degrees. Does this necessarily mean, though, that the two triangles JKL and MNP are the same size? And the answer is no, because with equilateral triangles, no matter the side lengths, their angle measures are all 60 degrees. So they didn't give us, again, enough information to say that these are congruent, because even though all the angles are congruent, we might have a triangle where these are all 2 and these are all 7. Right? Just because they're equilateral doesn't necessarily mean they're congruent triangles to one another. Their angle measures just happen to be the same. And we'll talk more about that coming up in the next few lessons. All right, so last couple pieces here. If triangles are congruent, are they going to have the same perimeter for number 4? The answer here is yes, because if triangles are congruent, all their side lengths are the same. So let's say their sides are all 3, 3, and 3. That means the perimeter is 9 when we add them all up, and it would also be 9 in the second triangle. So we would be able to prove that those are congruent, right, based on the fact that all their sides would have to be the same. Now, is it possible, however, to draw triangles that are acute and congruent versus a triangle that is right? Could they be congruent, the acute triangle and the right triangle? Well, the answer is no. Because if we have two triangles, that one that is right, it would have to have a right angle. And if another triangle is acute, it would have to have 3 angles less than 90 degrees, okay? So if they're going to have a 90-degree angle, it would turn into a right triangle and would no longer be acute. So all the angles would not match, and we know that's one of the criteria to be congruent. Okay, so we have to have the same size angles and sides. Okay. Number 6 and number 7 are really important. This is kind of the nitty-gritty of what you need to be able to do today. They're telling us we have rectangle ABCD divided into 2 congruent pieces. So if we look at this, we know that these pieces would be congruent, the side pieces would be congruent, and then the diagonal would kind of have to be congruent to itself, right? Imagine if we split this into 2 separate rectangles now, we would have rectangle ACD, and then we would also have rectangle ABC. So that, notice here, this rectangle this side is congruent to itself. It's kind of AC in both pictures, and so it's obviously going to be the same size. So if we fill in the blanks here to show, we know that AB in our one triangle is going to be congruent to DC in the other triangle. And again, this is where some color coding can be very helpful. We know that angle BAC, so BAC is this angle here, here to here to here. So BAC is going to be congruent to green to blue. That would be angle C here. So angle DCA. And then we know segment BC is the red segment. So here's BC. It's going to be congruent to AD. And then last but not least, we have angle ACB. So the blue and the red sides is going to be congruent over here to angle DAC. Okay. So again, the colors can be very helpful in helping us line up what is truly congruent to one another in our pictures. Last but not least, they do not give us a picture in the last one, but they do tell us the congruency statement. Okay, they're telling us that PQR is congruent to GHJ. So what we're going to do is we're going to look at which ones line up together, because Q and R line up with H and J, which means segment QR is congruent to segment HJ. And GJ is going to measure up, if we look at GJ, that is the first and last letter. So PR is the segment it lines up with. And then angle R is the third letter. Angle J is the third letter, so they're going to line up. And angle G, the first letter, is going to measure up with angle P, the first letter. So it's really important that when you name what is congruent to one another, you line up your similarity statement accordingly to make this go much faster as well. We'll work more with this in class. Thanks, everyone.